We are going to discuss about our next topic, which is all about polynomial curves, the tangents and normals to plane curves. The equation of a line of slope m through the point x1 and y1 is y minus y1 is equal to m times x minus x1, where m is of course equal to the first derivative. The normal to a curve at the point x1, y1 is defined to be the line through that point and perpendicular to the tangent line there. So in illustration, para mas maintindihan natin yung concept ng tangents and normals, for example, may isa akong curve and may isa akong point sa aking curve. Ito yung tangent line. The definition of tangent, it is the line that touches the curve at exactly one point only. And the normal line, in contrast, that is perpendicular to the tangent line. And so, for example, we have to find the equations of the tangent and normal lines at the point of the curve indicated. So, number 1, y is equal to 3x squared minus 2x plus 1. Our equation of the curve at the point 1, 2. So, we have to find first for the slope or for the y derivative of this equation. So, that is 6x minus 2. And then, that is our slope for the tangent line equal to 6x minus 2. And then, substitute natin yung x coordinate, which is 1. So, 6 times 1 minus 2, that is equal to 4. This is the slope for our tangent line. And in order to find for the slope of our normal line, that is the negative reciprocal of our slope for our tangent line. So, that is negative 1/4. And then, finding for the equation of our tangent line using this point slope form. So, y minus 2 is equal to 4 times x minus 1. y1 is equal to 2, our coordinate given. And our slope for the tangent line is equal to 4. And our x coordinate given ulit, that is equal to 1. And then simplifying, y is equal to 4x minus 2. This is the equation of our tangent line. Finding for the equation of the normal line using again the same point slope form, that is y minus 2 is equal to negative 1/4. Our slope for the normal line, which is the negative reciprocal of our tangent line slope, times x minus 1. And then cross multiplying 4 to the left side of our equation, that is 4y minus 8 is equal to negative x minus 1. And then distributing the negative sign, that is negative x plus 1. And so, our equation for the normal line is x plus 4y is equal to 9. Second example, y is equal to the quantity of 2x minus 1 cubed at x is equal to 1. And so, finding for the first derivative, using the power rule, so that is 3 times 2x minus 1 squared, because 3 minus 1 is 2. And then deriving the quantity inside, that is equal to 2. Or simplifying, that is 6 times 2x minus 1 squared. And then since x is equal to 1, we can substitute already. That is 6 times the quantities of 2 times 1 minus 1 squared. And then our slope for the tangent line is equal to 6. And then slope for the normal line is, of course, the negative reciprocal is negative 1/6. And since yung given coordinate lang natin dito is x, we have to find for the y. Using the original equation, y is equal to 2x minus 1 cubed. Hahanapin natin yung value ng y coordinate using the x coordinate value, which is 1. So, substitute natin yung 1 sa x. So, that is 2 times 1 minus 1 cubed. And so, y is equal to 1. So, ito yung isa-substitute natin sa y sub 1 sa ating point slope form. So, y minus 1 is equal to 6 times x minus 1 in finding for the equation of our tangent line. So, that is 6x minus y is equal to 5. And then, finding for the normal line equation, y minus 1 is equal to negative 1/6 times x minus 1. And then, cross multiplying 6 to the left side, that is equal to 6y minus 6 is equal to negative quantity of x minus 1. And then simplifying further, that is negative x plus 1. And so our normal line equation will be equal to x plus 6y is equal to 7. Our third example, y is equal to x squared minus 2x at y is equal to 3. So finding for the first derivative, in order to find for the slope of our tangent line, y prime is equal to 2x minus 2. And since wala tayong value ng x para masubstitute dito sa ating first derivative, kailangan natin hanapin muna yung value ng x using the y coordinate value, which is 3. So back to our original equation, y is equal to x squared minus 2x. Substitute natin yung value ng 3 sa y. So that is 3 is equal to x squared minus 2x. And then, transferring 3 from left to right. And then factoring out. So may dalawa tayong values ng x dito. The x sub 1 is equal to 3 and the x sub 2 is equal to negative 1. So ito yung dalawang isa-substitute natin sa ating y prime. So our first slope for our tangent line 1 is equal to 2 times 3 minus 2, which is equal to 4. And then our second slope for our tangent line also, tangent line 2, that is 2 times negative 1 minus 2 is equal to negative 4. And then the slope for the normal line is the reciprocal of our first slope for our tangent line, that is negative 1/4. And of course, for the slope of our second normal line is positive 1/4. And so we are ready to solve for our equations for our tangent line using these slopes and these intercepts. Using the point slope form, then y minus 3 is equal to 4 using the first slope for our first tangent line times x minus 3. Simplifying, distributing 4 to x and 3. So that is y minus 3 is equal to 4x minus 12. And then our tangent line 1 is equal to 4x minus y is equal to 9. And in finding for the second equation of our tangent line, that is 1 minus 3 is equal to negative 4, our second slope for our second tangent line. And then x sub 1 is our second value of x, which is negative 1. And so y is equal to, y minus 3 is equal to negative 4x minus 4. Simplifying, that is 4x minus y is equal to negative 1, our second tangent line. Finding for the first normal line, that is, our slope is negative 1/4 and our x is equal to 3 using the same y for all of our equations. So y minus 3 is equal to negative 1/4 times x minus 3, and then cross multiplying 4, that is 4y minus 12. And then our first normal line equation is x plus 4y is equal to 15. And then for the second normal line, using the second slope and the second value of x, that is positive 1/4 and negative 1. So y minus 3 is equal to 1/4 times x plus 1. Cross multiplying 4, that is 4y minus 12 is equal to x plus 1. And so our second normal line equation is x minus 4y is equal to negative 13. Fourth example, x squared minus xy plus 2y minus 2 is equal to 0 at x is equal to negative 2. Finding for the first derivative, that is 2x minus xy prime minus y plus 2y prime is equal to 0. Factoring out y prime sa terms na may y prime, so that is y prime times the quantity of 2 minus x is equal to y minus 2x. And then, dividing both sides of our equation by 2 minus x, our y prime is y minus 2x divided by 2 minus x. And so, dahil wala tayong value ng y, we have to find for that first using the negative 2 value for our x. Substitute yung negative 2 sa ating equation. The result, simplified, is 4 plus 4y is equal to 2. And then combining 4 and 2, that is negative 2, dividing both sides by 4, that is equal to negative 1 half. So this is the value of our y. And so back to our first derivative, substitute natin yung value ng ating y, negative 1 half, minus 2 times negative 2, divided by 2 minus negative 2. And so the slope for our tangent line is 7 over 8. This is the result of these fractions. And the slope for the normal line is, of course, the negative reciprocal of 7 over 8, which is negative 8 over 7. Solving for the equation of our tangent line using 7 over 8. So that is y plus 1 half is equal to 7 over 8 times x plus 2. Removing the fraction by multiplying our equation by 8. So that is 8y plus 4 is equal to 7x plus 14. And then 7x minus 8y is equal to negative 10 is our equation for our tangent line. Finding for the equation of the normal line, that is y plus 1 half is equal to negative 8 over 7 times x plus 2. And then multiplying 14 to our equation para ma-remove natin yung fractions. That is 14y plus 7 is equal to negative 8x minus 16. And so our normal line equation is 8x plus 14y is equal to negative 23. For our fifth example, that is y squared is equal to x cubed over 2a minus x at point A. So first derivative, that is 2y prime is equal to, apply natin yung quotient rule. So the denominator times the derivative of our numerator is 3x squared minus the numerator x cubed times the derivative of our denominator, which is negative 1 since constant yung ating a. And then squaring our denominator 2a minus x. And then transferring 2y from left to right by division. So, magiging denominator siya dito. And then, distributing 3x squared sa ating dalawang terms. So, that is 6ax squared minus 3x cubed. And then, multiplying both negatives, that is positive x cubed. And then, combining like terms, negative 3x cubed plus x cubed is equal to negative 2x cubed. And then factoring out the common 2x squared sa ating numerator. 2x squared times 3a minus x na lang yung matitira. Over 2y times 2a minus x squared. Canceling out 2 kasi common siya sa numerator and denominator. Magiging x squared times 3a minus x all over y times 2a minus x squared. Substitute natin yung x and y coordinates a and a. So for x, that is a, and for y, that is a also. So that is a squared times 3a minus a all over a times 2a minus a squared. And then, the result is a squared times 2a all over a times a squared. So makakancel out natin yung a squared dito, makakancel din natin yung a na 1 lang yung exponent. So our y prime is equal to 2. That is our slope for the tangent line. Negative reciprocal of that for our normal line, that is negative 1 half. And so finding for the equation of our tangent line, our y1 is equal to a. Our slope for the tangent line is 2. And our x1 is also a. And then distributing 2 to x and a, that is 2x minus 2a. And so our tangent line equation is equal to 2x minus y equal to a. For the normal line equation, that is y minus a is equal to negative 1 half times x minus a. Cross multiplying 2 to the left side. So that is 2y minus 2a is equal to negative x plus a. And then our normal line equation is x plus 2y is equal to 3a. And so that is it for the polynomial curves topic. For your questions, comment down on our Schoology. And then for our next topic, that will be all about the applications of the derivatives.